Okay, so part two of this understanding pests is going to be looking at plant diseases and weeds. So you have signs versus symptoms. Signs are the physical presence of a disease organism. In this case, we've got Nectaria canker, and so the fruiting bodies on this stem are the sign of the disease. Symptom is the result of an interaction of a disease organism and the plant. So here we have dogwood anthracnose, and the leaf has actually changed form because of the disease. Here we have bacterial canker with gummosis. The gummosis is the sign. Powdery mildew is a fungus, and so the fruiting bodies for that are the sign. So disease symptoms can interfere with some of the plant functions. Here we have crown gall, which can cause vascular wilt, canker, fruit rot. There's many ways in which some of these functions are interfered with by diseases. So types of symptoms include things like spots. So that's a distinct lesion. We have a leaf spot here on hydrangea. Blight is when you've got these spots that have merged together. So here's Septoria leaf spot on rubus. Rot is tissue breaking down, usually mushy, sometimes dry. And wilt is when a plant droops due to water stress. It may be systemic or due to root rot. So here we have bacterial soft rot on an onion, and there's going to be a very strong smell associated with this as well. And verticillium wilt is a fungal disease, and so that's going to show an entire stem or section of a tree may begin to wilt when the rest of it looks fine. Cankers are sunken lesions, usually on stems or woody tissues. It can occur on fruit. Here we've got bacterial canker on tomato, and then perennial canker on apple on the stems, and that this is a fungal disease. Galls are abnormal growths that occur on leaves, twigs, roots, and flowers of many plants. Here's crown gall on roots. Sometimes you'll see crown gall at the base of the stem at the soil line. That is a bacterial disease. Western gall rust is a fungal disease. So some of the symptoms you see caused by viruses include dwarfing. You might see a ring spot. You might see a mosaic pattern either on the leaves or on the fruit. So how do pathogens enter plants? Well, viruses require vectors of some sort, and you can be a vector. A few are by mechanical entry. So maybe pruning. Sometimes there's root grafts that occur that can spread viruses from one plant to another. Bacteria must enter through a natural opening or wound, and there's usually water associated with that. Fungi and oomycetes, which are water molds, enter through a natural opening or wound, or through the enzymes they produce, a few by vectors. So here's some different ways that diseases can enter into a plant leaf. And so a spore enters the stoma. Hyphae are long branching structures of a fungus, and aprosorium is actually the flattened, thickened portion of hyphae, and you can see that is able to penetrate into the leaf. Bacteria will happen through a stoma or some natural opening or wound. It has to have water associated with it. And leafhoppers spread phytoplasma, which are organisms closely related to bacterial disease. So in order to have disease happen, you need to have a favorable environment. So in the case of root rot, you need to have water present. A susceptible host, could be a plant, is susceptible to certain diseases, certain types of plants, or you've got a plant under stress that is making it more susceptible, and then the pathogen. Okay, so some pests are weeds. Here we have yellow archangel, which is a Class B noxious weed in Washington State. So when you talk about life cycle, managing weeds, you have to talk about their life cycles. So you have annual weeds, you have biennial weeds, you have perennial weeds. So annuals complete their life cycle in less than 1 calendar year. It's really 1 growing season. This is the easiest to control because they only reproduce through seeds. The weeds do persist, weed seeds persist in soil for years, and there are winter annuals and summer annuals. So here's a summer annual. So in the spring you're going to see the little sprout come up. It's going to continue to grow, it'll go to flower and then to seed, and then it'll die back in the fall. So lamb's quarters is an example of a summer annual. Winter annuals, you'll see these sprout up in the fall, and really this is the time you want to get these guys. They'll continue to kind of hang out until it starts to warm up, and then they'll start flowering, and in this case it happens very, very quickly, and then they go to seed really, really quickly before you even know it. You start trying to pull them and they're shooting seeds everywhere. So shepherd's purse is an example of winter annual. Biennials will have a rosette in the spring. They'll stay in a rosette form into the fall, kind of hang out, and then in spring of the following year it will start to flower and then go to seed. Sometimes it's a 3rd year. Biennials aren't perfect. Sometimes they are 2 to 3 years. But the time to manage this thing is in the 1st year before it has a chance to flower. Garlic mustard is an example of this. So perennials can be woody or herbaceous. They live more than 2 years. Their root systems are capable of food storage within 3 to 6 weeks after germination. They propagate through seeds, stolons, tubers, rhizomes, plant fragments, and rooting canes. So simple perennials resprout from crown buds on a taproot and spread by seed. Roots are large and fleshy. If you control the seed production, you're able to control the weed. And you can try cutting it back often. It eventually depletes the food stores. And of course our favorite plant, the dandelion, is a perfect example of this. So here's your simple perennial. 1st year, flowers, year after year after year. Creeping perennials, these are the hardest to eradicate. They reproduce through creeping roots, rhizomes, stolons, and seed. And Canada thistle is a prime example of this. Hedge bindweed, which we've all had to deal with, I'm sure. But you can see they just continually grow year after year. They've get these incredible root systems underneath, and sometimes you think you've got a sprout when it's actually just part of the same plant. And here's kind of a side view of Canada thistle, and you can see the extensive root system here.